There are different types of logarithm scales that people use that have been created to be able to make things easier to comprehend. We are going to work through 3 different types of scales in this class, the pH scale, the Richter scale, and the magnitude scale. So to start off, we have the pH scale. So this is used to measure how acidic or basic something is. And the pH scale ranges in values from 0 to 14. And if you get back that a pH is of 7, that means it's neutral. It's neither acidic nor basic. If it's less than 7, then it's acidic. And if it's greater than 7, then it's basic. So our formula for the pH scale here is that pH is equal to negative log of the hydrogen ion concentration. Or if we want to figure out what the hydrogen ion concentration is, well, that's 10 to the negative pH, and that will tell us the hydrogen ion concentration. The one thing that's not written here is that this hydrogen ion concentration needs to be in the unit of moles per liter, but we don't really worry too much about that in this class, as all of our examples and problems are going to have the hydrogen ion concentration in moles per liter, or you'll be solving for the hydrogen ion concentration already in that unit. So an example here first to start off with is that the concentration of hydrogen ions in water is approximately 10 to the negative 7th power of moles per liter. So that then means that our pH of the water is equal to negative log of 10 to the negative 7th power. And now this we can evaluate with our calculator. We can input negative log and then parentheses 10 to the negative 7th. And that should then give you that this is equal to 7. So that means our pH of water is 7. If you've taken a chemistry course, that should make sense. If you remember that water is what we consider neutral as long as it's pure water and doesn't have anything else in it. The next problem, we have that the hydrogen ion concentration for a brand of canned tomato sauce is 0.000051 moles per liter. So now we are asked, what is the pH of the tomato sauce? Well, our equation for pH is it's equal to negative log of the hydrogen ion concentration, and we have just been given the hydrogen ion concentration, so we can put that in to the parentheses here. So 0.000051. And now we can evaluate this in our calculator. And if we round to the nearest tenth, so 1 decimal place, you should get 4.3. And now, is the sauce an acid or a base? Well, we got the pH as being 4.3, and we know that 4.3 is less than 7, so that means that it is acidic. The next scale that we're going to talk about here is the Richter scale. This is used for earthquakes to tell us the magnitude M of an earthquake that has an intensity that is I times the base intensity of the earthquake. And the formula here is given to us as M equal to log of I, the intensity. So now, for an example, if we want to find the magnitude of an earthquake that was 750 times the 750,000 times the base intensity of the earthquake, all we need to do is to take that intensity and put it into our formula for I. So our magnitude is going to be equal to log of 750,000. So now this we can put into our calculator, and if I want to round to 1 decimal place, that should then give you 5.9 for the magnitude. And now people probably like to compare magnitudes of earthquakes because they're dealing with these smaller numbers that are more easier to comprehend, and then they can evaluate what different values of the magnitude will result in what type of earthquake, of how strong it is, rather than having to deal with these large hundreds of thousands of size values for the intensity. And then lastly, the last scale here is the decibel scale. And this one tells us our sound intensity, and we'd rather, instead of dealing with sound intensity, a lot of times people like the decibels to give us how loud something is. So our sound intensity is given to us here in this equation in the function notation, where the decibels of the intensity is equal to 10 log of I over I0, where I0 is our standard intensity threshold for a sound to be heard. I0 does have a exact value for it, but we're not going to actually work through it with those type of problems in this class, because similarly to how the pH hydrogen ion concentration always has the unit of moles per liter in this class, we are always going to be given intensities that are being multiplied by this I0, the base intensity, so that we don't really have to worry about it too much. So we have that in our example, a harp seal call has a sound intensity that is 9.2 times 10 to the 12th power times greater than the threshold level. So this here means then that our intensity of the harp seal call, I, is equal to 9.2 times 10 to the 12th power times greater, so that's being multiplied by the base intensity threshold level, which we're calling I0. So now let's find the decibel level for this harp seal call. So our decibel level of this particular I, which we have as being 9.2 times 10 to the 12th power times the I0, is going to be equal to 10 log of this I, which we have as being 9.2 times 10 to the 12th times I0. But then that's being divided by the I0 here from our formula. So now that standard intensity threshold, the I0s, they just cancel out and we don't have to worry about it. So now this is equal to 10 log of 9.2 times 10 to the 12th power. And this you can put into your calculator. So we can write it in exactly like this. And when you do that, you should get about 130 for our number of decibels of this harp seal call.